Here are your solutions to 7-5. These are the letter and guided practice problems. We'll start with letter A. They ask us to determine whether or not we have similar triangles here. So first of all, we can see right away that we have two angles, H and L, that are congruent because they're both 110 degrees. So there's one set of angles. Our next set of angles, angle JKH. Now I'm using the three-letter designation for this angle because otherwise both of these would be K. But because they are vertical, remember we learned this earlier in the year, because they're vertical we know that these two angles are congruent. So our other angle, MKL, is the same measurement. So we have two sets of angles that are congruent, two of the three in the triangles. Therefore we know that these are similar triangles. And we can say that triangle JKH is similar to K or MKL. So let's turn this on and you can see this. So we've got the first angle, the three-letter angle that we talked about, congruent to the other, and then of course H and L congruent, and therefore we know that the two triangles are congruent. All right, let's try letter B. At the same time that a 2-meter street sign casts a 3-meter shadow, so let's draw a street sign here, and it is 2 meters high, casts a shadow that's 3 meters in length. A nearby telephone pole, so let's draw the telephone pole over here. Telephone pole casts a 12.3 meter shadow. So let's extend this down here so we can write the shadow a little easier. So it casts a 12.3 meter shadow. How tall is the telephone pole? So as with all proportions, there are going to be many different ways to set this up. The way I'm going to do it is like this. We have 12.3 over x. So 12.3 over the unknown of x is equal to, I did this a little bit backwards, but we have 12.3 here, so the shadow, so we have to start with the shadow here. We have 3 over the height of the street sign, which is 2. So we have our equation, so we end up with 3x equals, that's 3 times the x, 2 times 12.3 would be 24.6. Divide both sides by 3, and we would get x equals 8.2. And we remember that we're talking about meters, so it's 8.2 meters. Just remember when you set these up, you could have done this many different ways. We could have gone 3 over 12.3, for example. 3 over 12.3 equals 2 over x. 2 over x. And again, we would have 3x equals 24.6. No matter how you set it up, it's going to end up the same way. The key thing is, whatever you do, if you do it shadow to shadow, or if you do it the height of the thing to its own shadow, that you have to be consistent with how you set up your proportion. Please press pause and do guided practice. Problem number 1. Determine whether the triangles are similar. If so, write a similarity statement. Right away we notice that these two are vertical angles and that makes them congruent, so we'll mark them. And then also we have these two angles are congruent, therefore we have two sets of congruent angles, so we have similar triangles. Now the key is to get this in the right order, so let's put the first one in here. First of all, you would have to say that angle YWX, so it's YWX, is congruent, not similar now, congruent to, that was YWX is congruent to V, this one here, VWU. Also, we could have angle X congruent to angle V. We showed that. And then lastly, therefore, we have triangle YWX is similar to triangle UWV. The key here is to make sure you have your letters in the proper order. Because Y and U are congruent, we have them being first. Because W and W, both of these W are congruent, those are next, and then X is congruent to V, those are the third letters. Make sure that you have those letters in order. They don't have to be in YWX order, but they do have to be matched up with the corresponding letter in the other triangle. Problem number 2. In this case, we can figure out this angle here by taking 180 degrees minus 90. That equals 90. So we get rid of this 90-degree angle. Now we need to subtract 35 from that, and that is going to equal 55. And there is no 55-degree angle here, so therefore we know that we do not have congruent angle or similar triangles. They are not similar. Problem number 2. We want to know how tall is the tree. First of all, they should have told us that we have similar triangles here, but because of the fact that there's shadows, they expect us to know that because the sun is far enough away that you can always consider those similar triangles whenever we're talking about shadows. So let's take a look at it this way. We're going to compare this to this and this to this. So we're going to have 0.3, 3/10 over 2 2/10 equals 45 100ths, 0.45 over h, our unknown. So we have 3/10 h equals 2.2 times 0.45 is 99 100ths. So we're going to divide both sides by 3/10. Divide both sides by 3/10, and we have h equals 3.3. And our unit is meters, so we're going to put meters on that. Problem number 4. Find the distance from the house to the street light. In this case, we are going to take 8 and obviously compare it to 4 because that is the outside of it. So we have 8 over 4 equals, now obviously we want to find out D, and that's on the 8 side or with the 8 triangle, so it's going to be in the numerator, and it's going to be D over, in this case it's 5. Make sure you understand that you would have to do a little kind of a rotation here in order to compare these. You'd have to turn this, we'll redraw it here like this, so that the orientation is similar to that, in which case we would have 4 here, and of course the 5 would end up here, and that's why the 5 compares to the D. So once we have that, we know we have 4D equals 40. Very easy math here. Divide both sides by 4, and we have D equals 10, and again it is meters, 10 meters. Our essential question, number 5, let's just turn the answer on. First of all, the question, how do similar triangles make it easier to measure very tall objects? And the simple answer to that is 2 objects and their shadows form similar right triangles. As I said on problem number 1, we can always assume that they are similar triangles because the angle of the sun is so far away. They're very, very, very close to exactly the same. If you can measure the height of one of the objects, you can use a proportion to find the measure of the other object. Just exactly like we've been doing for these problems. Please do independent practice.